Hello, mathematicians! Today we're going to learn about intersecting tangents and secant lines and how to find the lengths of the segments created by those intersections. In this first example, we have two tangent lines. We know that because they only intersect the circumference at one point. This is our point of tangency. Here, F is another point of tangency. And tangent lines have a special property where two tangents that are intersecting create segments of congruent length. We're going to call those A and B. It doesn't matter which one is which because those segments are congruent. So I'm going to just choose DE to be A and EF to be B. That's from another example. So DE and EF are going to be our two segments and they're congruent. Another way to say that is equal. So we can set them equal to each other. A is 5x, B is x squared plus 5x minus 36, and then we just need to solve algebraically.
So we're going to subtract 5x from both sides. And notice that it actually cancels out both. Now we have 0 equals x squared minus 36. Let's get this x by itself. Add 36 to both sides.
Now we know to cancel out a square, we need to take the square root of both sides. Square root of 36 is 6. Square root of x squared is going to be x. So here, x equals 6. Now if I wanted to find the length of DE or EF, all I would need to do is substitute in that x value. And you can use this to check your work because these two should be equivalent when we substitute that x value in. Six squared is 36 plus 30 minus 36. These two will cancel each other out, and both segments have length 30. In our next example, we're going to talk about the secant-secant product theorem. That's where we have two intersecting secants. Those are the segments that are going to touch the circumference twice and extend out those lines. So here, just like in the chord product theorem, we're going to choose our A and our B. There is a specific place that A needs to be, though. A and C are the exterior part of those secants. So here's A, here's C, because they're the outer portion, the part outside of the circle. B is going to be this chord that is along that secant with A, and D is going to be this chord. Now that we're going to plug those in, A is 7, A plus B would be 7 plus x plus 3. C is 6. C plus D is 6 plus 2x minus 6. And then we can go ahead and combine our like terms inside the parentheses because we've got multiplication happening here. So before we touch this outer 7, this coefficient, we're going to simplify. And we're going to simplify again. I'm going to distribute. And solve like normal. And same thing, if we wanted to find the lengths, we would substitute in our x value. Now we're going to simplify this a little bit, combine our like terms that are inside these parentheses.
2x, negative 7 plus 3 is negative 4.
Now we're going to do our double distribution.
Combine again.
starting with our highest power term. 2x squared is greater than 1x squared, so we're going to get rid of that one. Now we're going to move all of our x's over to the same side. This time we're actually going to get everything on one side and put 0 on the other. And you can think back to algebra when you were solving quadratics and factoring. So instead of getting all the numbers to one side and all the variables to the other, we want everything to be on the same side.
And I can actually do both steps at once if you guys don't mind.
These will cancel, so it's 0 on the other side. Now you have a couple of options. If you feel comfortable factoring, you can do that. If you do that, you'll get x minus 10 and x minus 14. And I'm not going to go through how to factor. You can look up other videos for that. But this is just one option. So instead of factoring by hand, we can go to Desmos.com. This is where a lot of you have been using the scientific calculator already, but we're actually going to graph. We're going to type in our function, which was x squared minus 24x plus 140. And then we can see that there are two solutions, 2 points where we are crossing the x-axis. Our first one is over here at 10, 0. So our first possibility is 10. And our second one is right here at 14, if I can get right on it. At 14. So our second possibility is 14. That's another method of getting those two solutions without factoring. Either method you choose, you realize that you have actually two solutions, 10 and 14. Those are actually both possible in this problem, but if you want to check the reasonableness and see if maybe one would not make sense, you can choose one of your segments or all of your segments and substitute them in. So I'm going to call this option 1 and I'm going to call this option 2. In option 1, length UV, that's my green segment, would be 10 minus 8. That would equal 2. UT would be 10 minus 7. That would equal 3. ST would be 10 plus 3, and that would equal 13. If we're using option 2, UV would be 14 minus 8. UT would be 14 minus 7, and ST would be 14 plus 3. So either of those actually will work for us. Now I'm going to challenge you on your assignment to tell me why one of the solutions may not be reasonable. Not a solution of this one, but a solution of the problem on your work. For our last example, we have the secant tangent product theorem. Obviously here we're going to have one secant line and one tangent line intersecting. And you'll notice that there's a little square here. That A has to be the tangent side. So that's going to be this portion right here. And then just like the last one, this is the outside. And D is the inside of the circle. And these are along the secant line. So here it actually matters where our A is. That's got to be the segment related to the tangent. So now let's substitute in our expressions. 3x plus 1 squared equals 3x minus 4. And then inside we need to add those again, just like we did on the last one, plus 15. We're going to do some simplifying. I'm actually going to expand this. Because squared means we're multiplying this by itself, so I'm expanding it. These will combine and we'll have 3x plus 11. Now we're going to distribute just like we did on the chord product assignment.
We have a double distribution. Combine our like terms.
Okay, and now we're going to solve like normal. We're going to start with the highest power term again. And you'll actually notice that we have 9x squared on both sides that will cancel out, leaving us with 6x plus 1 equals 21x minus 44. Three equals x. And then, just like all the others, if we want to find the actual segment lengths, we can just substitute in that 3. Okay, I hope you learned something today. Keep on learning. Let me know if you need help, and have a great day.